like this. So these are some of the notations which we may use. Now next is order of a differential equation. So what is the order of the differential equation? So the highest order derivative present in a differential equation is the order of the differential equation. For example, if I give you dy by dx is equal to e to the power x, then its order is 1, as one order derivative is present. If I give you d2y by dx square plus y is equal to 0, so here order is equal to 2, as second order derivative is present. If I give you an example, d cube y by dx cube plus x square d2y by dx square to the power 4. Can you tell me what is the order of this differential equation?
Also 3.
Yes, it will be 3. Order is 3. Highest order derivative is 3. Degree of a differential equation is the next part here. Degree of a differential equation. This is the highest power of the highest order derivative. So if we take, you can say highest power so if you see the definition, so I give you a definition here. Highest power of the highest order derivative. So if we talk about the examples here, like d cube y by dx cube plus 2 d2y by dx square to the power 2 minus dy by dx plus y equal to 0. So here degree will be, can you tell me the degree?
Also 1.
Yeah, it will be 1. That is the highest order is 3 and its highest power is 1. Then we have another example, dy by dx whole square plus dy by dx minus sine square y is equal to 0. Here degree will be, can we say it is 2 or 1?
So 2.
2. So the highest order derivative, there is only dy by dx, only one order derivative. Its highest power is 2. Then we have dy by dx plus sine dy by dx is equal to 0. Yeah, this is a very good example. Here, what we have to know one more thing is that if differential equation has derivatives, yeah, you can say if differential equation has, let me see their words, what they are saying. Hmm. Polynomial equation in derivatives. Polynomial equation in derivatives. This is important thing. If differential equation is not a polynomial equation in derivatives or cannot be reduced This also you can write, they have not written this. Then it is, its degree is not defined. So here, this third one is not a polynomial equation in derivative, because dy by dx is a polynomial, but sine of dy by dx is not a polynomial. It is a trigonometric function of dy by dx. Trigonometric function of dy by dx. It is not a polynomial equation. Polynomial equation means the derivative should have whole power. Okay, 1, 2, 3, so on. 0 can also be there. So here you will say that degree is not defined. Order is defined, order is 1, but degree is not defined. So for degree to be defined, the differential equation should be a polynomial equation in derivatives. Now, if we have dy by dx, let us write it like this, sine of dy by dx plus y is equal to 0. Can you define its derivative?
No.
No, but we can define. How? Sine of dy by dx is equal to minus y. So dy by dx equal to sine inverse of minus y. So this is no more, this is simply you can say this is a polynomial equation in derivatives, because the derivative is in the polynomial form. So you can reduce it also. They have not written this sentence, but it is also to be noticed that if you can reduce it, then its degree is defined. So its order is 1, degree is 1. So in above one, it was not possible, because if you would have taken sine inverse, then what will you will get? Dy by dx is equal to sine inverse of minus dy by dx. Same issue again. The derivative is a polynomial function, is not a polynomial function. So you have to again see this, whether you can reduce it or you cannot reduce it. Here you cannot reduce it, so its degree is not defined, but here degree will be defined. Is it okay?
Yes, sir.
Okay, for so example, from exercise 9.1, you can see a few questions. So these are small questions, 4, 7, 10, 12. You don't have to do much of calculation. You have to tell the order and degree, if degree is defined, of these differential equations.
So for the order is 2,
For 4,
and the
order is 2, correct?
degree is also 2.
Is sure?
Degree is not defined.
The degree is not defined because derivatives, it is not a polynomial in derivative.
For the 7th one, the order is 3 and the degree is 1.
Order is 3 degrees, correct?
10 the order is 2 and the degree is 1.
And degree.
For 12, it's 2.
For
The
10th,
order is 2.
for degree, 10th, what will be the degree?
So 1
Okay. And for 12th,
or A, 2.
order is 2, correct. Now we have to see general and particular solutions of a differential equation. Okay. There is nothing much to do here. What you have to do, let me give you a example. Solution means which is the equation of a differential equation. It satisfies it. So for example, exercise 9.2, question number 1, y is equal to e to the power x plus 1 is there, and y double dash minus y dash equal to 0. Verify that you have the given function is a solution of the corresponding differential equation. So this is the differential equation and this is the function. So this is a solution of the differential equation. We call it a solution of differential equation. How will we check it? So simply y double dash we find, first y dash we find, that is e to the power x, the derivative, and y double dash is again differentiated. And when we see that the left hand side, which is y double dash minus y dash, that will be e to the power x minus e to the power x, which will be 0, is equal to right hand side. So basically, this is the solution of the differential equation, which we can verify. So we don't have to do much of the thing here. So if we see one more question, like this is called general solution here. This is a particular solution. If there is a constant, then it is a general solution. For example, we can have second one. Second one, this is a particular solution. We can say this is a particular solution because there is no constant of integration. Second one, it is y is equal to x square plus 2x plus c. Now, y dash minus 2x minus 2 is equal to 0. You have to verify here. So what we will do, so here it has to be a general solution because constant of integration is there. So you will differentiate it. When you differentiate, what will happen? 2y dash is equal to 2x plus 2 you will get. And then you will write it as y dash is equal to x plus 1 by y. So this is what you will write it. Now you will come to the differential equation. So left hand side of the differential equation is y dash minus 2x minus 2. So it will be x plus 1 by y minus 2x minus 2. We'll write it as x plus 1 minus 2xy minus 2y. Now y dash, have we done it correctly? Oh, sorry, I have done it wrongly. The question was y, not y square. So y is equal to x square plus 2x plus c. I noted it wrongly. So in that case, you will get y dash is equal to 2x plus 2 and y dash is equal to 2 times of x plus 1. So when you put it in the left hand side, y dash is equal to 2 of x plus 1 minus 2x minus 2. This will be 2x plus 2 minus 2x minus 2 is equal to 0. So basically, this is the right hand side, which means this is a general solution. Why it is a general solution? Because there is a constant of integration c. In above one, there was no c here. It was all given values, constant. Here it is a constant. This is called general solution of differential equation. So have you understood?
So I don't understand the y dash minus 2x minus 2 part.
This is given in the question, no?
Oh, it's in the code. Okay.
Yeah, two things are given. One is the equation, another is differential equation. And you have to verify that this differential equation will give you this solution.
No question.
So you differentiate the function, put it here in the differential equation left hand side, and show that it is equal to right hand side. Got it?
No, yes.
So you can try a few questions like you can do five, 9, 10, 12 from exercise 9.2. Also do question number 11. 11 is little different from 12. So also do 11. I'm coming in a minute from washroom.
Oh, so what's the meaning of arbitrary constants?
Okay, that I will tell you. Have you done till question number 10?
Oh, yes, sir.
Okay, verified all of them are true.
Oh, yes, sir. The 9th and 10th is equal to 0, and the 5th one is equal to 8.
Fifth one is equal to x, y dash is equal to y. This you are getting ax. Fifth one, it would be like this. Since it is y is equal to ax, when you will differentiate it, you will get only a. And if you write the left hand side of the differential equation, it is x, y dash. So it will be x into a. And right hand side is y, it is x. So both are same. This you have done. Hello.
So I got so the differentiation of ax I got as a, and then the xy dash is equal to x. I substituted a in place of y, so that's equal to a.
You substituted you you substitute y dash as a and x will remain as it is. So it will be xa.
So the x's can get cancelled, right?
That is in the right hand side. Right hand side is y. It is ax. Y will x get cancelled. Y dash is a. This is y dash. How it will have it will cancel it. This is x as it is, and this is y dash as a. This will be xa,
Okay, so
and the right hand side is given as y, and y is x, so it will be also x. So left hand side and right hand side are both same ax. Hence proved.
so the left hand side will be the differentiation of ax, right?
Why the differentiation of x? It is given that you have the differential equation as x y dash is equal to y. This is what you have to verify now. This is given here.
Yes, sir.
Y is equal to ax is given. So when you see the left hand side, it will be x into y dash. Y dash would be a. X into a. You talk about y. Y is equal to x. So it will be x. Finally, both are same. Hence proved. This is how we will do.
Okay, sir.
Got it?
Yes, sir.
In others, do we need to discuss?
No.
Okay. Now, arbitrary constant is basically the c, which comes after doing the integration, indefinite integration. That is the constant of integration. For example, you have y is equal to dy by dx is equal to x square. So when you do the integration, you write it as dy is equal to x square dx, and you write it as y is equal to x cubed by 3. Integrate both the sides plus c. This is how you get the arbitrary constant. So if the order is 1, you will get one arbitrary constant. So if order is 2, you will get 2 arbitrary constants. Similarly, if the order is n, you will get n arbitrary constants. So this is the first thing. Another thing is that if it is a particular solution, this is about the general solution. This is the general solution. But if it is a particular solution, so in particular solution, we have been given some initial conditions generally, or some condition that suppose for x is equal to 1, y is equal to 1. So here if it is given that along with this, x is equal to 1, y is equal to 1. So when you get the final result, you put the condition that is y is equal to 1 and x is equal to 1. And you get the value of c that will be 2 by 3. So the equation will be y is equal to x cubed by 3 plus 2 by 3. So in that case, there is no arbitrary constant. So if there is a particular solution, then no arbitrary constant, whether it is of first order, second order, third order, because we get the value of the arbitrary constant and we put it in the equation. Are you getting this?
Oh, so you explain it again.
So for example, here in this differential equation, if there is some condition given like this, since you have got this solution and you have one arbitrary constant c, but when you put this condition, you put y as 1, x as 1, so you get the value of c as 2 by 3. So arbitrary constant has a fixed value 2 by 3. So you then put it here. Then you get y is equal to x cubed by 3 plus 2 by 3. So this equation will have no arbitrary constant. This is called particular solution. Above one, this one is called general solution. Got it?
Yes.
So if you talk about question number 11, the number of arbitrary constants in the general solution of a differential equation of fourth order are, what you will say? If the differential equation is a
So
fourth
for
order, arbitrary constant will also be 4. 12th one says the number of arbitrary constant in the particular solution of a differential equation of a third order are. Particular solution, how many arbitrary constants you will find?
so 0.
0, correct. That is the answer. Now let us come to third exercise. Have you written this?
Some writing.
Okay.
Done, sir.
Okay. Next is formation of a differential equation whose general solution is given. So for example, we have here first I'm taking an example, then I'll give you the way. Form the differential equation representing the family of curves y is equal to mx, where m is arbitrary constant. So remember, our task is to get rid of arbitrary constant. So when we try to get rid of arbitrary constant, how we get rid here? Y is equal to mx is there and m is arbitrary constant. So we write it as y is equal to mx, and then we differentiate it. So dy by dx is equal to m after differentiating, because differentiation of x is 1. Then using this equation and this equation, what we can do is we can write y is equal to m is dy by dx into x. So y is equal to dy by dx into x. So this is the answer. This is the differential equation. Now, if suppose we have a question like this, so remember the thumb rule is to get rid of arbitrary constant. Suppose y is equal to a sine of x plus b is there. And here a and b are arbitrary constants. So our purpose is to get rid of a and b both, right?
Yes, sir.
So when we'll differentiate it, we get y dash equal to a cos of x plus b on differentiation. This is the first order derivative. A will remain a, sine will become cos. Now we'll differentiate it again. So y double dash is equal to minus a sine of x plus b. So cos will become sine with a negative sign, because cos differentiation is minus sign. Now, how can you get rid of a and b in a step? So if you see these three equations, what you can do, first and third will help you a lot. How? That can we from first and third write y double dash is equal to minus y? Can we write it like this?
Yes, sir.
Okay. So y double dash plus y is equal to 0 is your answer. That means you can write it like this, that it is d2y by dx square plus y is equal to 0. So this is the second order derivative. So what happens that this one is having order 1. Why it has a order 1? Because the arbitrary constant was only one arbitrary constant. Here we have two arbitrary constants, a and b, and you have to get rid of both. That is why here we have to order 2. So always you will see that the order of the differential equation will be same as the number of arbitrary constants. Have you written it?
Yes, sir.
Okay. You may have word problems also, but first let us see few questions on this. Then we'll see word problems also. So exercise 9.3, try question number 2 and 5.
So 9.2 and 9.3 are not in quotient, right?
Okay, are they deleted from the syllabus for board?
I'm pretty sure because we didn't.
Do you have the syllabus right now with you? Can you see it?
Oh, so 9.2 and 9.3 on the.
Okay, so leave them then. Let us come to 9.4 exercise. Methods of solving first order, first degree differential equation. Okay. The formation of differential equation they might have left from the syllabus. So we come to solution of differential equation. So we have solution of differential equation. The first method is variable separable. This is the most basic method. So here what we have is to simply separate the variable. I will give you an example here. Like we have a differential equation dy by dx is equal to 1 plus y square by 1 plus x square. So when you will separate the variable, you will get dy by y 1 plus y square equal to dx by 1 plus x square. We will separate these variables. That is 1 plus y square will go in the denominator here and dx will go in the numerator here. Now you will integrate. So this will be tan inverse of y is equal to tan inverse of x plus c. So this will be your answer. So variable
Okay, sir.
separable is this. Okay. You can see one more example. Like we have is given that it is a word problem. Find the equation of a curve passing through the point minus 2, 3, passing through a point minus 2, 3, given that the slope of the tangent to the curve, given that the slope of the tangent to the curve at any point xy is 2x by y square. So first of all, you have to find the differential equation. What is the differential equation? Find the equation of a curve passing through the point minus 2, 3. This portion we will deal later. Given that the slope of the tangent, this portion we will deal first. Given that the slope of the tangent to the curve at any point xy is 2x by y square. So what do you mean by this statement mathematically? What is the slope of the tangent to a curve?
Oh, so dy by dx.
Yeah. So this is dy by dx. And this is equal to
2x by y square.
2x by y square. So this is first we have formed the differential equation. Now, when we will write it, y square dy is equal to 2x dx. I will integrate. That is the variable separable. That is y with dy, x with dx. Y cube by 3 plus x square. Sorry, equal to x square. 2 will cancel plus constant of integration. Now you have got this general solution of the differential equation. But it is given that find the equation of curve passing through the point minus 2, 3. That means x is minus 2 and y is 3. So this is what we have to do. As I told you earlier, though that is not a part of the syllabus, that is going to help you here. So x is equal to -2 and 3 cube by 3 plus c. This will give you the value 9 is equal to 4 plus c. So c is equal to 5. So this is you will get constant of integration, the arbitrary constant. So therefore, y cube by 3 is equal to x square plus 5. This will be your answer. This is the required
Okay.
question. So you may get word problems also, and you have to find the differential equation according to the word problem, then solve it. So based on these examples, are you writing this?
Some.
Okay. So let us do a few questions from 9.4. Four, 10, 13, and then let us see 1, 2 word problem. 17 and 19. You can try these questions. And if you have the answer with you at the back of the book, then you can side by side also keep checking the answer. So for which you will get the answer, we will not discuss. For which you will not get the answer, we will discuss.
So for the 10th one, I was able to total the in integration part. I'm not sure to go after that.
So 10th one, you have done the variable separation.
Yes. I got integration of ex by ex minus 1
Okay.
is equal to integration of sec square by tan y. Sec square y by tan.
Yeah, correct. So sec square y by tan y dy on the right you are getting. And on the left you are getting e to the power x by e to the power x minus 1 Now you have done so much of integration, you should not face problem. So it is like you can take e to the power x minus 1 as t. So e to the power x dx will be equal to dt. So this will be numerator will be dt, denominator will be t. And tan y you can take as u. So sec square y dy is equal to du. So you get log of t is equal to log of u plus constant of integration that you should not forget. Log of t is e to the power x minus 1 plus log of u is tan y equal to, which is equal to plus c. Now, one thing keep in mind, they generally reduce it into exponential when there is log as a final answer. So write it like this, log of e to the power x minus 1 by tan y, because on subtraction, it will go in division by log property is equal to c. So e to the power x minus 1 by tan y is equal to e to the power c. So change the log into exponential. This they mostly do. They don't keep in log, they change in exponential. And e to the power c is also a constant of integration. So it is also written as another c. So that c can also be called as c. So e to the power x minus 1 is equal to c tan y. This may be your answer. You can check from the back. Please confirm from the back.
Oh, so it's tan y is equal to c in the brackets 1 minus e raised to x.
That is the same thing. Actually, what they have done while uh, placing them. So what we can do is 1 by c e to the power x minus 1. This you can write like this one. And tan y is equal to 1 by c, and minus we can take common, minus 1 by c, 1 minus e to the power x. And that is another constant, so that call it as c. We generally do this thing that we take a constant as another constant. If it is multiplied, divided, power of another constant, we write it same constant sometimes. So obviously these are two different constants, but for denotation that is arbitrary constant. So this can also be written like this. This is what it is given there.
Yes.
Okay, that is no issue. So generally they do this. You can write both as the answer. Both are correct. Both c are not same, but you understood na ki basically you can take this as k, that becomes c, then that becomes some other constant l, and finally the whatever constant comes they call it as c only. For the that c actually denotes constant of integration or the arbitrary constant. So finally they always write it as c.
Oh, so I'm not able to read the fourth one.
Fourth one, okay. This you have noted it down.
Yes, sir.
Fourth one, sec square x tan y dx plus sec square y tan x dy is equal to 0. So this would become sec square x tan y dx is equal to minus sec square y tan x dy. In the next step, we write it as sec square x dx by tan x is equal to minus sec square y by tan y dy. I don't think there is much of an issue here. Is it okay till here?
Yes, sir.
So you have to integrate both the sides. So when you will integrate both the sides, you will get Again, tan x is u, so above is du, so log of u. Now you can directly think about it instead of doing all that process. Minus log of tan y. Can we write it like this?
Yes, sir.
Let's see. Now let us take both one side. So log of tan x into tan y by the log property is equal to c. So tan x into tan y is equal to e to the power c. So we can say tan x into tan y is equal to e to the power c, and e to the power c is also c. So this is 100.
So no, the class today was for 1 hour. So is it fine we end it now?
Okay, okay, no issue.